Hello everybody and welcome to this episode of Programming and Algorithms. In this episode we're going to look at software development methodologies from the 1980s to present date. So as we mentioned, software development methodologies are how we manage the process of developing software. So we've seen the 50s to the 70s, and now let's look at the 80s to present date. So the spiral model, I think, is an interesting example of a methodology developed in the 80s. Developed by Barry Beam in his paper, A Spiral Model of Software Development and Enhancement in 1986. It was published by ACM. Barry Beam is a very famous software engineer. His work is extremely well known. That's him there. His argument is that a linear approach to software development is a bad idea, and he would prefer a more iterative model. So he created the spiral model, a four-stage model in essence. And the key questions of the model are, what do we do next? And how long will we continue to do that thing for? So he's identified that there are issues with the waterfall model, as Royce did before him. And he says the spiral model is a better approach. So this is the spiral model. In essence, what it says is, build a prototype using a waterfall model style approach. Do a risk analysis of what bits are good and what bits are bad about it. Then, based on that, reiterate and create another model using a waterfall type approach. Then do a risk analysis on that and keep building prototypes until you've created an operational prototype or a production model. So the risk is the main element that's new in this, and I suppose dimension 1 is identifying what's required. Part 2, or quadrant 2, is to figure out what alternatives are available. Part 3 is to do your risk assessment, and then part 4 is to fully develop and test the completed system. So in Beam's mind, there are 10 risks in terms of developing software that need to be managed, and he lists them as personnel shortfalls, they don't have the ability, unrealistic schedules or budgets that are too small, developing the wrong software functionality, developing the wrong user interface, gold plating, adding too much on, a continuing stream of requirement changes, shortfalls in externally furnished components, and that's a big deal now with libraries and things like that, shortfalls in externally performed tasks, real-time performance shortfalls, and then straining the computer science capabilities of the developers. So we move on to the 1990s, and we have two models here, one that I'm very fond of called the VModel, and another which is rapid application development. So the VModel, I guess, there's been a lot of suggestions as to who created it. For me, the paper, The Relationship of System Engineering to the Project Cycle by Forsberg and Moz, is really, I think, an important milestone in the VModel. So 1991. And what they say is, a new way of portraying the technical aspect of the project cycle clarifies the role and responsibility of system engineering to a project. This new three-dimensional graphic illustrates the end-to-end involvement of system engineering in the project cycle, clarifies the relationship between the two, and encourages the implementation of concurrent engineering. So they say that the waterfall model has problems. They say that the spiral model is good, but they don't see how clearly design is articulated in the spiral model. So what they say is the user and developers need to go on a kind of V-shaped journey. So this is it. So if we start at the top left and go down and then come up to the top right, really how I think of this is, it is almost the waterfall model again, with on the left-hand side of the V is the analysis, the design. The coding is at the bottom of the V, and then the testing elements are coming up the right-hand side. The key thing is, though, that stages on the left-hand side are married with stages on the right-hand side. So each part of the design is married with some part of testing. So little bits of code we design on the left, we design the testing for them at that time, and then they're tested, and the overall architecture of the system as described on the left is tested on the right. So there's various stages in it, and really the goal here is to really refine what the user wants and to refine it down to an agreed but minimal set as possible, then to design or describe those requirements in detail. This is actually the graphic at the back of the paper. It's a highly complicated, highly documented approach, but it can be very effective for large-scale projects. That's a nicer version of it, and I think this gets to the point I was making. If we look at the left V, the left leg of the V, we have validation planning, getting the user requirements, describing the system requirements, designing a tech architecture, and doing a detailed design. Then there's the build at the bottom, and then for each of those we've described on the left, we do a complementary set of tests on the right. So our detailed design tells us how we need to unit test. Our technical architecture tells us how we need to install test. Our system requirements tell us our system testing, and our user requirements tell us our user acceptance testing. And finally, our validation planning gives our validation reporting. So this nice mirroring of each stage in design, allowing us to, or informing, each stage in the testing. Another methodology developed in the 90s was RAD, or Rapid Application Development. That was created by James Martin in his 1991 book, Rapid Application Development. So James Martin is a British computer scientist who, as it happens, was nominated for a Pulitzer Prize for his book, The Wired Society, as well in the 70s. So how he sees RAD is that there's 4 bits to it, 4 legs in a stool, almost 4 legs on a table. Requirements planning, design, construction, and then testing and implementation, or testing and operation. And he sees RAD as being very applicable for systems that need it when you have the user available to you. So in some ways, RAD is another variation on the software waterfall lifecycle model, but you do analysis, design, build and test, and then do that maybe several times. So you do it quick and do it often rather than simply doing it once. And again, this would be exactly what Royce recommended in the 1970s. Conceptually, RAD says a table idea of tools, people, management, and methodology are the pillars upon which RAD is built on. So the theory here is RAD delivers systems fast in a lightweight way using existing tools. So by the 1990s, there were a lot of prototyping tools already available. So that is to say, people could build stuff using pre-existing libraries of software and using nice little tools. So it allows for a quicker creation of software. We move on to the 2000s now, and at the start of the 2000s, we got what is called the Agile movement, or Agile software development. So a bunch of software engineers got together, including famous names like Kent Beck, Alistair Cockburn, Martin Fowler, Andrew Hunt, Ron Jeffries, Robert Martin, and Dave Thomas, and created this manifesto, which they call the Manifesto for Agile Software Development, in 2001, where they said they were very dissatisfied with existing methodologies, how software development projects were being managed. And they said we need to refocus because there seems to have been a growing focus on documentation. So they met at a resort to discuss in 2001, had a good time, and figured out, let's create a manifesto for how software should be done. And this is the manifesto. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools. working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. That is, while there is value in the items on the right, we value on the items on the left more. So individuals and interactions are more important than processes and tools. Working software is more important than comprehensive documentation. Customer collaboration is more important than contract negotiation. And responding to change is more important than necessarily following a plan. So this is agile, lightweight, it's quick to change. It allows us to be responsive to factors within the software development process. That was a manifesto, but each of the individuals involved in that, and many other individuals since, have developed their own specific methodology for implementing that manifesto. Some of them include what is called agile modeling, or the agile unified process, or dynamic systems development method, or essential unified process, or extreme programming, which can fit into other methodologies, feature-driven development and test-driven development, the open unified process, Scrum, and velocity tracking. So there's a range of ways that the 17 developers have chosen to implement a concrete planned approach to developing the Agile Manifesto. So these techniques are lightweight, and they're considered to be very effective in getting software created quickly. I think now that we are in the age of extensive libraries of software and lots of prototyping tools and wireframing tools and things like that, and now that customers realize they have to be involved a lot more in the development process, the agile methods are finally possible to do. But nonetheless, I would see what Royce proposed in the 1970s as being closely allied with the ideas proposed in the Agile Manifesto. So that's it. Thanks very much. We'll see you on the next episode.